Hi everyone. Today we are going to understand what are microservices and what is microservice architecture. Before we understand what are microservices and what is microservice architecture, it's important to first grasp the concept of monolithic architecture because microservices emerged to address the problems of monolithic architecture, providing number of benefits and features. Monolithic architecture will consist of various modules including numerous functionalities, all sharing the single database, developed and deployed as a single unit. We need to combine our whole app including all of these modules and functionalities into single code base, and it will use only single CI/CD pipeline. In short, like we can wrap up all our coding into single app which can be developed and deployed as a single unit. Now let us understand what are the major drawbacks of monolithic application. So first is the scalability. Due to its tightly coupled nature, it leads to challenges such as scalability issues. Scaling a monolithic application means scaling the entire system. It's difficult to scale individual components independently. Higher infrastructure cost. Scaling the whole system instead of individual services can be costly. Development and maintenance challenges. Slow development for large apps. As the code base grows, development, debugging and understanding becomes more and more complex. Even minor changes can affect the entire system, raising the risk level. Slow deployment and updates, like since the entire application is deployed as a single unit, even a small change requires rebuilding and redeploying the whole system. There is a technology lock-in as well. All components must use the same technology stack, limiting flexibility in adopting the new technologies. Like for example, if we have used the Java tech stack for creating original application, then we have to use Java only for adding or creating a new feature into existing app. High downtime risk. A failure in one part of the application can bring down the entire system, leading to outages. There is a longer release cycles as well. As the code base grows, testing and deployment take longer, delaying new features and bug fixes. Although there are several drawbacks, these are some of major ones that led to the rise of the microservices. Over the period of time, as the list of drawbacks kept on increasing, companies began searching for an alternative solutions. And in 2009, Netflix adopted microservices as an alternative, and to their surprise, it worked well for them, leading to great results. Microservices are a software architecture style where applications are broken down into smaller, loosely coupled and independent services. Each one is responsible for a specific function. They often use the service registry for a dynamic service discovery, along with features like API gateway, load balancing, fault tolerance, and distributed login to ensure scalability and reliability. How microservices works? A client request is sent to the API gateway first, which will further take help from the service registry to determine which microservice to call, and finally it will route the request to the appropriate microservice. Now let us understand what are the advantages of using microservices. First is the scalability, like services can be scaled individually based on demand. Next is the independent services, like each service is self-contained and can be developed and deployed separately. There is a decentralized data management. Each microservice manages its own database or data storage, preventing a single point of failure. Technology agnostic, like different microservices can use different programming languages, frameworks and databases. Fault tolerance or isolation. If one microservice fails, it does not necessarily bring down the entire application. Easy maintenance and updates, like microservices are loosely coupled, making it easier to modify, update or replace individual components. Better team productivity. Small and cross-functional teams can focus on independent services. This will encourage agile development and faster iteration cycles as well. Enhanced security and compliance, like security policies can be applied at the microservice level. Sensitive data can be isolated in a specific services, improving compliance with GDPR as well as HIPAA, etc. And better performance optimizations, like specific microservices can be optimized without affecting others, which will help in reducing latency and improving response times. Next is the reusability, like microservices can be reused across different applications, which will reduce redundancy and speed up development. And finally, it will support cloud and DevOps, Like microservices works well with cloud-based deployments, which will integrate seamlessly with DevOps practices for automation and monitoring. Now let us understand how microservices communicate with each other. Like there are two main ways of communication, like one is the synchronous and other is asynchronous. So what is synchronous? Like sender microservice will wait for a response from the receiver before its next execution. The examples of the synchronous communication is the REST APIs with HTTP protocol and gRPC like Google Remote Procedure Call. What is asynchronous? Like the sender microservice does not wait for a response from the receiver and continue its execution immediately after sending the request. The examples of the synchronous communication is a message queue, for example Kafka or RabbitMQ, and gRPC comes under both like synchronous and asynchronous communication based on how it is used. Now this is the REST API communication. Through REST API, like our product service will send a HTTP request to the stock service endpoint, and the stock service will give a HTTP response back to the product service with the help of the REST APIs. Next is a gRPC. Like here, gRPC, the two services hosted on different resources can communicate directly, calling each other's functionality over an HTTP2 protocol or connection. The functions must be defined with identical definitions in the dot protofiles of each services. gRPC basically creates a server-client relation between microservices. And there is another communication approach which is comes under asynchronous way using the message queues. Like the message queue is a queue that routes messages from the sender to the receiver. This approach decouples the sender and receiver without being tightly coupled. Now every architecture comes with the advantages and disadvantages as well. Let us see what are all drawbacks of using a microservices. Like there is increased complexity, like more services means more moving parts, making the system harder to manage. It requires proper service orchestration and communication mechanism. Difficult deployment and monitoring, like managing multiple microservices requires advanced DevOps practices. Monitoring and debugging and logging across multiple services is a complex one. High network latency, like microservice communicate via APIs using HTTP, gRPC or messaging queues, which will add network overhead as well. And latency issues may arise due to frequent service to service calls as well. Data management challenges, like each microservice may use its own database, making data consistency difficult, like which will require strategies like event sourcing, cores or distributed transactions. And there are inter-service communication related overhead as well, because services rely on REST APIs, GraphQL or gRPC or message brokers like Kafka, RabbitMQ. So purely designed communication can cause bottlenecks and increase latency. And there is a cost of infrastructure, because microservices require more services, containers like Docker, Kubernetes and cloud resources. More databases, more brokers and monitoring tools increase operation cost as well. Now let us see when to use microservices. Like when we require scalability, when we have large teams and distributed development, when we need independent deployments, resilience and fault isolation when our application requires, and when we want to go for continuous integration and continuous delivery, because if we are aiming for faster or more frequent releases, microservices can make it easier to implement CI/CD. Like since microservices are smaller and more independent, we can deploy and test individual services without waiting for the entire application. Next, like when we require cloud native and containerization environments, like microservices are well suited for cloud native environments and are often deployed using containers like Docker. If our infrastructure uses container orchestration like Kubernetes, microservices offer a natural fit. If we have complex domains, like if our application involves complex business domains with distinct subdomains, like microservices approach allows us to break down the system according to these domains, leading to more manageable and modular components. and if different parts of our system require different security rules or compliance requirements, for example, let's say payment processing and user authentication microservices, we can isolate these parts into separate microservices, making it easier to enforce specific security measures for that. So these are some scenarios or situation where we can use the microservices. There are other scenarios as well wherein we can use microservices, but these are the major scenarios. Now, I hope you must have enjoyed, so please do not forget to like, subscribe and share, and thank you very much for watching this.